In this problem, we have aspirin is prepared from the reaction of salicylic acid and acetic anhydride to produce aspirin and acetic acid. Some key concepts to remember before solving the problem. Limiting reactant, it is a reactant that is completely consumed in a chemical reaction and it limits the amount of product. And theoretical yields, and it's based on the limiting reactant and it's the amount of product that can be made in the chemical reaction. So now we're going to find the limiting reactant and identify the theoretical yields. And the problem that we're using today is, what is the theoretical yield in grams of aspirin when 2 grams of salicylic acid is heated with 4 grams of acetic anhydride? How many grams of excess reactant are left unconsumed? And if the actual yield of aspirin is 2.21 grams, what is the percentage yield? So now we're looking at this portion of the problem. And so we have the molar masses for what we need in this problem. So now we're going to start off with the 2 grams of salicylic acid. And then we're going to multiply that by 1 mole of salicylic acid. And we're going to have 138.12 grams of the salicylic acid under here because we want to eliminate the grams. And then we're going to multiply once again 1 mole of aspirin, and we're going to have the 1 mole of salicylic acid on the bottom because we also want to eliminate the moles. We have 180.15 grams of aspirin and 1 mole of aspirin on the bottom, and because we want to get grams at the end, we have this on the top. And then we get 2.61 grams of aspirin. Now for the second part, we have the 4 grams of acetic anhydride, and we want to multiply that by 1 mole of the acetic anhydride and the 102.9 grams of acetic anhydride because we also want to eliminate the grams. Multiply that by 1 mole of aspirin and have 1 mole of acetic anhydride at the bottom to eliminate the moles. And finally, we're going to multiply 180.15 grams of the aspirin and have the 1 mole of aspirin at the bottom to eliminate the moles because we want to get grams as the answer. And when we do this in the calculator, we get 7.06 grams of aspirin. So now we want to look at both of these answers. And we want to get the smallest one. So this means that the 2.61 grams of aspirin is the theoretical yield because the salicylic made the least amount of product. So this one would be the limiting reactant. In this part of the problem, we're looking at how many grams of excess reactant are left unconsumed. So we need to know how much of the acetic anhydride is needed to consume all of the salicylic acid. So we start off with the 2 grams of salicylic acid that we used here, and we're going to multiply that by 1 mole of salicylic acid over its molar mass, and then we're going to do the mole ratio. So we're going to multiply 1 mole of the acetic anhydride over 1 mole of the salicylic acid. Then, because we want to eliminate the moles of acetic anhydride, we put the 1 mole on the bottom, and then we put the molar mass of the acetic anhydride, and that gives us 1.478 grams of the acetic anhydride, and that is the excess used to require all of the salicylic acid. So in order to find how much of the excess reactant we're left unconsumed, we have to start off with the 4 grams of acetic anhydride given and subtract it by the 1.478 grams of the acetic anhydride. And then that gives us 2.522 grams of acetic anhydride. And this is the final answer to get the excess reactant, which is the reactant that occurs at a greater quantity than required. Now for this third part of the problem, we're looking at if the actual yield of aspirin is 2.21 grams, what is the percent yield? We're going to use this equation to find the percent yield, which is actual yield over theoretical yield times 100. So now we put the actual yield, which is what is given, 2.21 grams of aspirin, over the 2.61 grams of aspirin, where we got with finding the theoretical yield. When we do this in the calculator, we get 84.7%, which is when we multiply it by 100, and that is the percent yield. So these are the final answers that we got for theoretical yield, the excess reactant, and the percent yield.